Welcome back. This is a basic concept problem video. In a previous video, we went over the basic concepts of a electrical circuit, which we went over charge, current, voltage, and power. That video will be linked in the top right of this video right now. So in this video, we have 4 problems. The first problem, we're asked to determine the total charge transferred over a time period of 0 to 10 seconds when the current is as follow. So we know that the current I of t is equal to the change in charge all over the change in t. If we manipulate that, we get the change in charge is equal to the current I of t times the changing time. If we integrate that, we get that, well, let's put the integration sign. We get that charge is equal to the integration, and we have that the interval is 0 to 10 seconds, I of t dt. So we can then go ahead and say the charge is equal to, we can bring the half out and then integrate the current from 0 to 10 seconds. Just put I of t. Let's put t dt. We then get 1/2 t to the power 4, 0 to 10 seconds. And that is, evaluate this expression for 10 seconds and 0 seconds. So therefore we get that the charge is equal to 25 coulombs. So that's it for that problem. Let's go to the second one. As in the first video, we know that Q is equal to I times T. Here we see we're giving the charge and we're giving time. Time is in seconds, so we do not need to convert. So we can find the value. What is the value of the current? So we can manipulate that, and we get I is equal to charge over time. The charge is 300 coulombs, and the time is 30 seconds. So the current is equal to 10 amperes. So we can then go ahead and do the third video, well, the third problem. So as always, we read and we see that we have a current and we're giving time, and we're asked how much charge is deposited on an object. So we're still finding charge. So that means Q is equal to I times T, and we know that we're giving 10 kiloamperes, so that's 10 e to the 3 times 15 microseconds, e to the negative 6. That cancels out, so we get a charge. We get a charge of 10 times 15, 150. We're left with e to the 3, e to the negative 3, which is milli, so that would be millicoulombs. So the charge deposited on the object is 150 millicoulombs. So for the fourth problem, 2 question signs. So we know we're going to have to find 2 parts. So a rechargeable flashlight battery, so we're dealing with a battery, is capable of delivering 85 milliamperes of current for about 12 hours. Okay. How much charge can it release at that rate? So if the terminal voltage is 1.2 volts, how much energy can that battery deliver? So as always, we know that when we're dealing with charge, we know that the time should be in seconds. So 12 hours. So we know that an hour is 60 minutes. So 60 minutes, 1 hour, we can just put an hour there. And we know that an hour is 60, we know that a minute is 60 seconds. So we can just put M there. So therefore, we know that our time will equal to, let's put this right here, and that should be, let's put that in the calculator. So that is going to be 43,000, so that's be 43,200 seconds. Okay, so that's the time in seconds. I had to use my calculator for that one. So we know that power is equal to work, or in this case, energy. So just use E all over time. So therefore, we can find the energy, which is equal to P times T. However, though we're asked, the first thing we're asked is the charge. How much charge can it release at that rate? So that would be, our charge would be Q I times T. And in this case, our current is 85 milliamperes times 4. Just put T for this. We know what T is, so I'm just going to put T. I'll just write it out. So it's 43,200. Use my calculator for that one as well. And that will be 3,672 coulombs. So the total charge it can release at that rate is as follow. Then we go over to the energy. So the energy, we don't have power, but we know that power is also equal to V times I. We have the terminal voltage of the battery, and we know we have the current the battery can deliver. So we then go ahead and say the energy is equal to V, 1.2 volts, the current 85 milliamperes, and the time, which is 43,200, and we know that the energy will then equal to, punch that out, 4,000, so that'd be 4,406.4 joules. Energy or work is in joules. So that's it for today's problem. And as always, I forgot I listed that up here already, which we have. So we always want to convert our time into seconds. And the equation that we use, or the equations that we use, is that we know that current is relatable to charge and time, power, energy over time, and we know the power is V times I. This right here, we can achieve this by saying that, so power is equal to W over T, voltage is equal to W over Q, and current is equal to Q over T. So as you see, the reason why we can write power as V times I is because P is equal to W over Q times Q over T, which we then see goes back to W over T, which is power. And that is in the concept video, which we linked in the top right of the screen at the first part of this video. So go and watch that. It's pretty informative. So I'll see you in the next one. Bye.